I had the lowest GPA of anybody admitted to UCLA that was not on an athletic scholarship. I think it was, I don't know, somehow I get braggy about having gotten into UCLA with such a low GPA.
Are you proud of that?
I am.
That's good.
Thank you.
I like that.
Appreciate that. Help me out if you will, and grab out a playing card.
What?
Take your card. And show it to everyone else. I won't look.
What is it?
Well, if she told you, I'd probably hear it.
Turn it up.
All right. Yeah, put it in such a way that I won't be able to see it, and call stop as I go through the pack.
What, do I put it on it?
Just call stop.
Stop.
Throw your card back in there. Losing her card towards the center of the pack. Can anybody shuffle? Can somebody do it? All right.
Wait, no, that wasn't good enough. Because I didn't do it.
Do you need help, Christian?
Great. I think the most effective way for the next trick, if we will, maybe we'll do a couple magic tricks before getting into the math stuff. Place your hand palm up. Perfect. Your playing card would be the four of hearts, correct? Seriously? What was your card?
He was a king at 9.
Take a look. Help me out, if you will, and touch another playing card.
How you do that?
Just touch, don't grab it. Any idea what that playing card is? If we took a look and it just happened to be her king of diamonds.
Oh no, I'm sorry.
Let's give her a round of applause. Here, watch. We can take the king. I'm going to place it towards the center of the pack. A little riffle, a snap, and he jumps back up the top of the pack.
You spraying too much.
I can't smell. You smell it?
Yes, it's
But as opposed to the magic, I wanted to talk about the math ideas that Buckminster Fuller taught me when I was 12. This guy Buckminster Fuller suggested that all the math I'd been taught up until that age was basically kind of bogus. And so I think it's rather brave of Mr. Andrews to allow me to come to the class to kind of say that the math that we're taught in public schools and private schools is largely bogus.
That's great.
Thank you.
They've told me that before.
Right? The idea of a two-dimensional plane only exists in our mind. There's no place in the universe, there's no place on Earth where there is such a thing as a two-dimensional object. It just can't exist. Both Buckminster Fuller and Albert Einstein said that when you try and represent the universe in fewer than 4 dimensions, it's absurd. And the way that he began in sharing ideas of the absurdity of what we got taught was by drawing a circle on a piece of paper.
Move your hand, buddy.
How many circles are on the board?
1.
Right? And if we were to use a piece of paper as opposed to this board,
2.
well, how many on this piece of paper?
1.
Right, 1. This piece of paper in topology, that's a fancy form of math that it's for what basic structures are. This is a solid. A donut, which has a hole in it, they call that a torus. The tennis ball, solid, right? The way to turn a solid into a torus, put a hole in it. It's now a torus. But can we agree that the tennis ball and, without the hole in it, the piece of paper are basically the same? They're both solids? Whoops. Right? Would you draw a circle on the tennis ball? Uh-huh. Anywhere you want. Cool. So how many circles are on the tennis ball? Right. Would you fill in the circle?
Would it kind of suit because of the tennis ball itself?
That's a fantastic question. That's a brilliant question you're asking. We're going to get to that in about 3 minutes. But you're onto something there. So you filled in the circle, right? Now, if you were to keep making the circle larger and larger and larger, at a certain point that circle would be large enough that it would go around the equator, right?
Yeah.
And then if you kept making it larger, right. So it winds up begging the question, like if you look at a billiard ball, like an 8-ball, is an 8-ball a black ball with a small white spot, or is it a white ball with a black spot that's so large it almost encompasses the entire ball?
Never got that deep into a picture.
Well, it makes it a little bit ambiguous. But Buckminster Fuller's point was that you can't draw one circle. That what you're actually doing is drawing two. You're drawing a division between the small circle and the bigger space. You're drawing a division between what he referred to as the microcosm versus the macrocosm. And that our educational system, the way that we're taught geometry, teaches us small thinking. It teaches us to only see the small circle. It teaches us to only see the microcosm. And Buckminster Fuller's goal was to help people think bigger. And in 4 dimensions. Because that 2-dimensionality, that's just imaginary, everything exists in space, length, width, height. We get taught to think of a piece of paper as 2-dimensional, but the piece of paper actually has height, and it exists in time. And that's what makes it 4-dimensional. What he imagined was the importance of noticing the way that Euclidean geometry shapes our minds is the impact that it has on us of only seeing the smallness, only seeing the microcosm, only seeing the tiny part that we focus on. And yet his big quest on Earth was the question of how do we make the world work for 100% of humanity in the shortest possible time through spontaneous cooperation without ecological damage or disadvantage to anyone. And part of his solution was to change the way that we get taught math. He suggested that the language in which we get taught math gets humans to square off in war and speak in weaponry language, and that if we followed the principles of nature, we would be triangulating towards sustainability. Anybody know what this object is? Straws? It's actually also is a cube. But you notice how a cube can't hold its own shape? And so squares can't hold their own shape. A square can't hold its own shape. There aren't many squares in nature. The triangle holds its own shape. If you make a structure out of triangles, this is called a tetrahedron. It's the simplest structure that can be found in the universe. It's got 4 sides. It holds its own shape. Where if you make a structure out of squares, it falls apart. It can't. The fancy word for this in topology of holding its own shape is statically indeterminate. The fancy word for this is mushy? I don't know. But it's not statically indeterminate. It won't hold its own shape. And has anybody ever heard the term sacred geometry? Sometimes here in Nashville and the woo-woo areas they talk about sacred geometry. And sacred geometry is the Platonic solids. And Platonic solids include the tetrahedron and the octahedron. And has anybody ever seen a 20-sided die? The 20-sided die, like in Dungeons and Dragons or other games, that's an icosahedron. It's got 20 sides. And up until the 20th century, people were saying that in math, that you couldn't see how the Platonic solids would unfold through each other. And Buckminster Fuller said, well, actually you can. And he described the value of what he called a jitterbug. Technically, it's a vector equilibrium, and we'll get to it in a moment, but this is a jitterbug or a vector equilibrium. And if I squeeze this a little bit, if we were to put struts in between where the squares are that make it a little squeezable, we'd get a 20-sided object. We'd get an icosahedron. If you keep squeezing it down, you get the octahedron, the 8-sided. And if you keep squeezing it and turn it, this is the tetrahedron. The importance of this was showing how the smallest objects in the universe can go from the smallest unit, a tetrahedron, and unfold and refold and twist to become the octahedron and the icosahedron, showing that those Platonic solids are unfolding from each other. Now, you often won't notice the impact of the language that we are taught on how we see the world. They talk about Inuits having over 24 words for snow and ice, and so they see over 24 different kinds of snow and ice, where here we see snow and sleet and a couple other things. But there's also the impact of when we get taught to see squares, we see squares. And yet the squares don't really exist except as human inventions. And Buckminster Fuller suggested it's not a coincidence that humans have such a propensity for squaring off with one another when we're taught this divisive language. Now, to spark things off, or to keep things going in energetically, I imagine you guys might want to see some more magic.
Yeah.
All right. You wanted to help with something? My name is Ben. Your name is?
Jeremiah.
Good to meet you, Jeremiah. Jeremiah, I'm going to ask you to practice lying in a couple minutes. Is that all right?
I'm a good liar.
All right. Well, this time I'm going to be working with Jeremiah on his ability to lie. I'm going to have you pick a card, and then I'm going to shuffle the deck, and then I'm going to show you a few cards in a row. And regardless of what card I show you, Jeremiah, I'm going to ask you to say the 2 words, "That's it." The look in your eye, the tone of your voice, I'll know when you are lying and when you are telling the truth. All right? So first, take a playing card. Very good. Show them. I won't look.
Let me see. Make sure you show me that's it.
Come here, Jeremiah. Let's go.
Hey.
And then put it back down on the table when you're ready. Is it down?
Yes.
Thanks. Jeremiah, call stop as I go through the pack.
Stop.
Throw your card back in there. Hopelessly losing his card towards the center of the pack. Now place your hand palm up, if you will. Now, no matter what card I show you, what are the 2 words you're going to say?
That's it.
Very good. Your playing card was the 7 of clubs, correct?
That's it.
Very good. Your card is the Jack of spades, correct?
That's not it.
You're supposed to say that's it.
Well, that's it.
All right. Your card is the 2 of diamonds. Very good. One last playing card would be the 10 of hearts.
That's it.
You see, I can tell. You went slower. Your voice went down a little bit. This is your playing card, correct? For real. What was your card?
That's it.
What was your card for real?
It's in here.
Show me.
What the fuck?
Because you see, that's it.
How do you do it?
Whoa! Years of practice and self-denial.
Come here. I got it.
The question of how did I do it? I've learned systems that make things easier for me to follow. And part of what Buckminster Fuller was suggesting about geometry is that when you see the natural patterns in geometry, it sometimes is easier to figure out the answers.
I got a question.
Okay.
Are you possessed? Like, how do you? What's your method? How do you do it?
That's a lot of questions in a row. What do you mean by am I possessed? Am I possessed by the Holy Spirit? Do I feel faithful and religious on a moment-to-moment basis? Is that what you're asking?
No, I'm asking like, how do you do this? These great tricks.
Thank you. Practice.
Practice. I mean,
Having
it
a
can't be
mentor?
It has to be some type of magic.
It is sleight of hand and trickery.
So you like a wizard?
I would not call wizardry sleight of hand and trickery. But there are tricks to make math easier. For instance, I'm more visually oriented in some ways than others, and when taught about parallel lines and which angles would be congruent, which angles would be equal, I got taught to look for patterns of z's and x's. Who can see, anybody want to circle or trace a z or an x that they see up here? Would you mind going ahead and tracing the z? Just draw where you see the z. Excellent. You guys see that? You see the z? And guess what? These two angles in the z are congruent. They're the same angle. So when given one of these questions with a parallel line and a line going through it, when you can spot the z, you know that those two angles are congruent. Somebody else, can you see an x? Who can see an x? You want to come up here and trace an x? Great. We'll use a red for an x.
I don't see that, y'all stupid. Y'all stupid.
She don't even see it.
Fantastic.
Is that it?
Yep, that's an x. There's a couple others.
Where?
With it. Yep. Can you see the x right here?
Oh!
No.
Duh!
And with an x,
Duh.
these angles are congruent, and those angles are congruent.
Wow.
So when I see the patterns, first thing I do for these things are look for the x's and z's. It's easier for me to see the x's and z's than to remember the complicated stuff that I got taught as to why two angles are congruent. Does that make sense? And so we can take this to another level and in a different way. And it relates back to that question of me doing the magic tricks and being asked how. And if you know a little secret, it can allow you to do something that might look extraordinary and yet could have an easier solution than possible. This is something that's called a magic square, but there's nothing actually magical about it. But I imagine that you guys have noticed that Mr. Andrews has music playing often when you come into class?
Yep.
That jazz stuff.
That jazz stuff, exactly. You've heard about the left and the right side of the brain?
Mm-hmm.
And the right side is often the creative side, and the left side is the analytic side, dealing more with like math and computation. And if you stimulate the right side, often with like jazz or classical or non-lyrical music, music without words, it allows the left side, the analytic side, to work more efficiently. So in a moment, we're going to play with a math problem I'm going to have here. Would you mind choosing a number in a moment?
Yeah.
Cool. I want you to choose a number that's higher than 20 and less than 100. And If you want to make it easier to follow, probably choose something between 20 and 50, but if you want to choose 98, you can. It just makes it more entertaining if it's lower than 50. But you can choose whatever number you want. You have it in your mind? What's your name?
Joe.
Thank you, Joe. And so, Joe, in a moment, Mr. Andrews is going to play some background music, and that's going to stimulate the right side of my brain, while the left side works out some calculations. So, Joe, what number would you like me to use?
Like the number I thought of?
Yeah.
35.
35. So with a little background music, I'm going to work out numbers, so in any given direction, it's going to equal your number 35. We're ready, Mr. Andrews. All right. I don't think that's it, what we used last time. Is it? There it is. Yeah, it is. So if you want to take out a calculator and add along with me, you can, but watch this. 15 and 1 is 16, plus 12 is 28, and 7 is 35. Joe, you chose 35.
Yeah.
11 and 8 is 19, 14 is 33, 2 is 35. 5 and 10 is 15, 3 is 18, 17 is 35. 4 and 16 is 20, 6 is 26, 9 is 35. Try up and down. 7 and 2 is 9, plus 17 is 26, 9 is 35. 12 and 14 is 26, 3 is 29, 6 is 35. 1 and 8 is 9, 10 is 19, 16 is 35. 15 and 11 is 26, 5 is 31, 4 is 35. Try the diagonals. 15 and 8 is 23, 3 is 26, 9 is 35. 4 and 10 is 14, 14 is 28, 7 is 35. Try the center set of 4. 8 and 14 is 22, plus 3 is 25, 10 is 35. Try the corner blocks. 15 and 1 is 16, 11 is 27, 8 is 35. This corner block. 12 and 7 is 19, 2 is 21, 14 is 35. 3 and 6 is 9, 9 is 18, 17 is 35. 5 and 4 is 9, 16 is 25, 10 is 35. Try these two and these two. 2 and 17 is 19, 11 is 30, 5 is 35. These two and these two. 6 and 16 is 22, 1 is 23, 12 is 35. Try these two and these two. 7 and 2 is 9, 11 is 20, 15 is 35. These two and these two. 17 and 9 is 26, 4 is 35 is 35. Try the top set of 4. 1 and 12 is 13, 8 is 21, 14 is 35. This set, 10 and 3 is 13, 6 is 19, 16 is 35. My favorite are the cross diagonals.
No!
5 and 16 is 21, 2 is 23, 12 is 35. 11 and 1 is 12, 6, 18, 17 is 35. Even the outer four corners, 7 and 15 is 22, 4 is 26, and 9 is 35. Yes, I could.
I don't know.
We need to give you this number. That number was too easy.
Yeah.
All right, so you want to give me another number, and we'll do it again.
72.
Do a number up on the 50 though.
Sure.
Over 50.
I keep hearing people say 72, but I'm open to a different one.
No, 40 is John.
I heard a lot of people
No,
say a
make it
number
higher
above
than
50, so
Make it like
Bro.
higher than 50.
60!
what number?
62!
Is everybody fine with 62, or we want something really big? 81. How about we do 81?
No, that's simple, because 9.
All right, so not 81. Yes, your choice. 97.
Yeah!
Oh my.
Turn up the camera.
I'm going to get a calculator. Wait. I don't know if it's Saturday or something. Because it's David's time. But it's like his birthday. That was the reason I went to the store. So it's today.
You ready?
Yeah.
47 plus 11 is 58, plus 22 is 80, 17 is 97. 21 and 18 is 39, plus 46 is 85, 12 is 97. 15 and 20 is 35, plus 13 is 48, 49 is 97. 14 and 48 is 62, plus 16 is 78, 19 is 97. Try up and down. 12 and 17 is 29, 49 is 88, is 78, 19 is 97. 22 and 46 is 68, plus 13 is 83, plus 16, I'm sorry, is 81, plus 16 is 97. 11 and 18 is 29, plus 20 is 49, 48 is 97. 47 and 21 is 68, plus 15 is 83, 14 is 97. Should I go through all of them, or you believe me?
Can I try
You
it?
got it right.
Yeah, I did.
Can I
Where do you
try
get the
it?
numbers from, though?
Here's the lowest
Like,
I
47.
Well, when the music ends, what I'm going to go ahead and do is explain to you how I do it so quickly. I cheat.
What?
I cheat.
Wow.
Why?
How?
How can I cheat with math? I use a matrix of memorized.
Okay.
What the?
Oh.
Yeah.
Take it
Yeah.
over.
I see.
You just memorize it. Yeah, I know that.
Can I try it?
Sure, in just a moment. This is how I did the first one.
Hold on.
So basically, we would just write that.
Don't spray that.
Yeah. What was the first number we chose?
It was
35.
35. So what is
Stop!
what is 35 minus 20? 15.
That was rude.
What is x minus 1? 15 minus 1? What is x plus 2? 17. And x plus 1? 16. This is x is 15. So that was the original formula that I used. When we used a much larger number, I simply added 10 to each of these numbers that weren't an x, and made it minus 50. Does that make sense?
Yeah.
A little bit.
I won't spray anymore.
Seems hard, though.
It does seem hard. It is somewhat hard, and yet when I showed it, it was impressive, and so for me it was worth being a show-off to memorize these formulas. But we often get taught in math some of the longer, harder ways to do something than is necessary. Like multiplying anything by a zero is easier than multiplying something that doesn't have a zero, right? So if you wanted to square a number like 25 in your head, like anybody want to try and figure out what 25 times 25 is? Can you do that in your head?
That's simple.
Okay.
25,500.
It would be 625.
What?
25 squared, 25 times
How many
25.
quarters? How many quarters?
If you had 25 quarters, how much would you have? You'd have $6.25. Now we get taught to do 25 times 25 like this. 5 times 5 is 25, carry the 2, 5 times 10 is 12, plus 2, 125, a 0 here. 2 times 5 is 10, carry the 1. 2 times 2 is 4, plus 1 is 5, and then you get 625.
How do you do it?
Thank you for asking. How I do it, 25 squared, I go up to 30 and down to 20. So I multiply 20 times 30.
Which,
What's 2 times 3?
60.
6.
So it's
And then add 2 zeros,
600.
600. Plus 5 squared, 5 times 5 is 25. So 600 plus 25 is 625.
That's simple.
Right, and that's how I do it in my head, is a simpler way.
That's easier.
That is easier.
How did you learn that?
I learned that method from Arthur Benjamin and through working with Buckminster Fuller and some people that said, here are some non-traditional approaches to mathematics.
So, have you been to talk with people across the world, or?
At times. I perform magic in Switzerland and Japan, and I regularly lecture on mathematics and autism. I'm autistic, A lot of people, when I say that, will say to me, "You don't look autistic," which appears to me as absurd because I am autistic. So there's no way for me to not look autistic since I am autistic. And so I don't know what to do when somebody says to me, "You don't look autistic." Sometimes I say something a little bit caustic. I used this in Mr. Andrews' last class. This kid goes, "You don't look autistic." And I said, "And you don't look ignorant, and yet here we are." And then that kid got a little frustrated with me later and needed to keep talking over me. And bless his heart, and I didn't mean to square off with him, but I really don't know what to say when somebody looks at me right in the eye and they go, "You don't look autistic."
You really like
And I'm like, I look however I look, and since I am autistic, I imagine that I do look autistic. Because I can't not look like what I am. Making sense? So that is what it is. In April, I'm grateful for Mr. Andrews allowing me the space because it allows me rehearsal. In April, I'm going to be giving a talk on geodesic math, what we've been talking about, the ideas of the square and not being statically indeterminate in the tetrahedrons, and the idea that the way we're taught Euclidean math teaches us to see one circle when that definition changes our mind and makes it so that we only see the microcosm, so that we only think small, as opposed to seeing the function of a circle. And the function of the circle is a division between the small space and the big space. And oftentimes I think that our education system is about getting people to think small, to see a small space in a bigger system, as opposed to allowing people to start with the universe and think big and imagine how we might change the system in which we are embedded. And to me, that's why I do this work, is because I imagine that as we get open to new vocabulary, new language, we might find more common ground and stop squaring off and start triangulating towards sustainability. And I get back to that notion of what Buckminster Fuller was solving for, which is asking the question, how do we make the world work for 100% of humanity in the shortest possible time through spontaneous cooperation without ecological damage or disadvantage to anyone? Questions?
I'm hungry.
That's not a question.
Are you hungry?
That is a question. I am a little bit, and I have 2 Fig Newton bars in my bag. May I give you one and I'll have one?
Yeah, sure.
Right on.
I never
Did
turn
I
down
vote?
food,
No.
sir.
Sure.
You know that, man. Where did my
Oh, this
get
one, right?
dirty about saying I didn't want it? You know,
Wait,
like,
where do you work at? Where do you work at?
I don't. I'm grateful to not work. I used to work in advertising. I used to be the lead strategist on Singular Wireless. I was Senior Vice President, Director of Brand Strategy, and I was the #2 architect of a $500 million a year advertising budget. And it was my job to figure out how we could best spend that $500 million in order to influence and persuade people to buy more Singular wireless phones as opposed to Verizon or T-Mobile's or the other
I have a
competition.
question.
All right?
Am I going to turn to like one of
Wait,
those?
is it 5 spaces or 4?
4.
Are these one of those like really nice bars where like you turn to like some powerful guys?
My mom would like to think so. She gave me a bunch of these for my birthday. Now, I don't think she wants to turn me into a goddess, but I do go by the gender-neutral Dr. Ben Mack.
This tastes like perfume.
Yeah?
You keep spraying it.
I can't smell
One
it,
too many.
but I think it tastes pretty good.
You said it tastes like perfume.
Are you recording?
Okay, what's the number? Give me a easy number.
24.
This is really good.
Turn the music on.
Where'd you get this?
Oh, she's gonna do it. My mom.
That's
Do
what
that.
told me so. Well, I have to go get you some.
That's not the inspirational music. Here it comes.
Cause she looking.
This is,
I mean, I
there was another one we
I
used
need
the
something
first
better
time.
with
The first one's better.
I think it's first. Yeah,
not do that, bro. She already got 24.
Oh, fucking.
You already got a nice. Wow, I don't like no planes.
That's too much.
Kirsten got it too.
Wait.
You got it right. Because I searched it up and it smells like piss.
Yay! Let's give her a round of applause. It works. That
Some of
works.
them work, but not all of them.
Well, it works horizontally and vertically across all of them, right? Yeah. That's amazing. Well done. Good job, Harrison. So, here's how I would have done it.
I can't smell shit.
You must still smell that smell you had on the
What? A little bit of. Make some eggs.
Like, is it really?
Yes.
I should have like.
Oh, I have to.
I can't smell it.
That simply works all of the different ways that I did before. This is based on 35. If you use 1 through 16, you'll use all of the numbers with 35.
Wait, say that again?
So the formula, if you use 1 through 16 and use each of them once, or 34, sorry.
That really is good.
So you use all the numbers 1 through 16.
Yeah.
Yeah. I really is. I can't smell it.
Wait, guys, let's play.
We could get fancy and look for patterns. If you guys were interested, I could show you how using A, B, C, D, and 1, 2, 3, 4 that this formula got architected. But that might be going into more granular detail than you guys want. Where would you want to take this if we were to continue talking about math and wait a little bit longer before doing another card chart? Is there any math-related question? No? An interesting factoid about geodesic domes. You've seen those houses, or like Epcot Center, that are made out of triangles? You know the structures I'm talking about? Seen some around town? There's a smoke shop on Merriman that's in a geodesic dome. Talking about? It looks like a circle, or it looks like a dome, but it's got triangles on it.
It looks like a turtle.
It looks like a turtle, sort of. Yeah. So, an interesting thing about geodesic structures is that there's more pressure pushing out than gravity pulls down.
What is a geodesic?
A geodesic structure is one of those domes that are made out of triangles. Mr. Andrews, could you pull up an image of geodesic dome? Is there a way to, the projector up there?
Are you talking about this?
There you go, yep.
What's that one in Florida that you were mentioning earlier?
Epcot Center
Epcot Center?
at Disney World is all made out of triangles and is probably the most famous geodesic dome that's out there. And this gentleman has some on his laptop that are brought up. These structures are domes, and they are the most economical, there we go, of shapes. It's hard to see that those are made out of they're made out of glass. It's hard to see the triangles that are there.
Are those real?
Those are real. Maybe searching for simply images of geodesic domes as opposed to the Wikipedia page.
Now, is that how America is?
How America is.
So, are we around a glass ball like that?
Yep. Yep.
I honestly think the whole world is around the ball like that, and the government controls the weather. I know that's kind of weird.
Well, there are a lot of people that take that idea quite seriously, one of whom was Adolf Hitler, who imagined that there was like a canvas tapestry around the earth, and that stars were the holes in that tapestry. And Adolf Hitler literally thought that that's what stars were. That stars were the holes in that fabric that was around Earth.
I've never thought about it that way. That could be true.
I think that thinking along those lines has its real peril, because I don't think that Adolf Hitler is somebody who I'd call an admirable thinker.
He's a good person. I mean, he's not a good person, but he's like, he's human, you know what I mean?
Some would argue that he was perhaps one of the least human. He was a featherless biped. I wish he had gotten into art school. I consider him one of the least compassionate people on the planet. I mean, he did architect killing 8 million people. And it takes a certain genius to kill. Yeah. Yeah. So he was human. It just takes effort for me to see the humanity in him. I think he might have gotten bitter out of not getting into art school.
Was he upset?
About a lot of things.
Oh.
Right?
I feel bad, man.
I don't. I mean, I don't know.
I feel bad. He killed himself and 8 million people because he didn't get into art school.
Right?
Fucking terrible. You know,
so this is a geodesic dome. This structure here, to me what's most fascinating when you see one of these geodesic structures is that they're more likely with age to break by a strut popping out than collapsing in. Like when you see an old barn or an old house that's collapsing, it's folding in on itself. You know why it folds in on itself?
Why?
Because it's a cube, it's squares.
Why?
It can't hold itself up.
Why?
Because when we began today, we were talking about how triangles hold their own shape, but squares don't. If you wanted to build a gazebo in your backyard, a gazebo, a shed, like a shaded area to like have a picnic with your family or something, and you wanted to do it the cheapest, strongest, easiest way possible, you could simply get 5 hinges and bolt the 5 hinges together and the struts, and you wind up building, we didn't finish this in the last class, but an icosahedron, which is basically, this is one more complicated. That's an icosahedron, that red and blue one scrolling up a little bit.
This one?
That one right there, that red and blue toy structure.
Yeah.
If you can scroll up a little bit, we'll see it on the screen up here.
No, hold on. It is that, Joe. I didn't know you were talking about.
There you go.
This one?
Yep.